This is problem 33 from your review. It tells us we have a weight of tomatoes, it's a random variable x, we have a mean and a standard deviation. So our expected value, or our mean, for our tomatoes is 10 ounces. So we expect each tomato to be about 10 ounces, but it will change a little bit. And to tell us how much it might change, it tells us that our standard deviation equals 1.2 ounces. And from there you could find your variance. So your variance of x will just be that 1.2 squared. So 1.44. So now let's let our random variable w be the weight of our tomatoes in pounds. And it tells us that 1 pound equals 16 ounces. So we want to know the new expected value and standard deviation. Well, you need to write an equation for your new variable. So we have our original variable x. We need to change it to w. Well, if 1 pound is 16 ounces and we have ounces right now, we'll just divide by 16 to get to pounds. So w is going to be x over 16, or I prefer to write it as 1 over 16 times x. So to switch to pounds from ounces, you divide by 16. So now expected value. So the expected value of w, well, instead of w, we can say, well, w is really 1 over 16 times x. Now, our rules for our combinations of random variables say that if you have a number in here times the x, you can just bring it out. So it'll just be 1 over 16 times the expected value of x. And the expected value of x is 10 ounces. So 1 over 16 times 10 gives me 0.625. So we'd expect each tomato to be about 0.625 pounds, but we know it will change a little bit. Now, we always find our variance first, because some rules don't work if we try and do it in standard deviation. So we'll find the variance first. So variance says we'll just do the variance now of the 1 over 16x. But if you have a number inside here, it will come out still. But when it comes out, you have to square it. So it'll be 1 over 16 squared times the variance of x. So 1 over 16 squared times the variance of x, which is this 1.44. Which gives me 0.005625, and the standard deviation for w, which our textbook writes like that, most people write standard deviation of w, would just be the square root of the variance. So square root of 0.005625 gives me 0.075. Now for part B, suppose we pick 4 tomatoes from the bin at random and put them in a bag. Let's let y be the weight of the bag containing 4 tomatoes. What is the mean and standard deviation? So we'll write our new equation. Y would be equal to the weight of our 4 tomatoes. Now each tomato you pull out is not going to be exactly the same. That's the whole point of these problems, is each tomato is a little bit different. So I can't just do 1 tomato times 4, because again, each tomato is different. So I have to do the first one plus the second one plus the third tomato plus the fourth tomato. Again, because each tomato will be different, we have to add up 4 tomatoes instead of multiplying. That makes a difference when you find your variance. So the expected value of y is really just the expected value of x1 plus x2 plus x3 plus x4. And if you want to find expected values and there's a sum, you just do each one individually. So expected value of x1 plus expected value of x2 plus expected value of x3 plus expected value of x4. So we just add up each of the expected values. So the expected value for each individual tomato is 10. So 10 plus 10 plus 10 plus 10 gives me 40. Now you have to do variance instead of standard deviation first. So variance will be the same thing. Variance of x1 plus x2 plus x3 plus x4. And for variance, the variance rule says you just add up each individual variance. So variance of x1 plus variance of x2 plus variance of x3 plus variance of x4. Okay. Now each individual variance is this 1.44. So this is going to be 1.44 for the first one, plus 1.44 for the second one, plus 1.44 times for the third one, plus 1.44 for the fourth one, which gives me 5.76. So that's my variance. Again, you have to do variance first, then you do standard deviation. So the standard deviation for y is just the square root of that. So square root of 5.76 gives me 2.4. So that's my standard deviation. I'm going to stop the video here so that you can try see on your own. There is just a hint. Okay, I just want you to remember from basic math, so review from math not related to this problem. If I have something like 3 minus 5, that is also the same as 3 plus negative 5. So if you remember, technically a minus is just adding a negative. That will help us. So we could also say this is 3 plus negative 1 times 5. So if we had something like a minus b, we would say that is really like a plus a negative 1 times b. Okay. So if you have it in variance, you need to write it like that, so you can pull out the negative 1 and you're going to square it inside your variance. And negative 1 squared gives you positive 1. So that's my hint for part C.